A rod of length L has a total charge Q distributed uniformly along its length. It is bent in the shape of a semicircle. Find the magnitude of electric field at the center of curvature of the semicircle. So, in order to solve this problem, I am first of all deducing a general equation for electric field due to an arc of charge. And then we will put the necessary values and we can easily solve this kind of question. So, for this particular question, we are saying that a particular rod of length L, something like this, is having a plus q charge distributed along its length. So if plus q charge is distributed along its length, so we can say that lambda is charge per unit length. Charge per unit length, or we can say that lambda equals q by L, which we will use later in the problem. Now it is bent in the form of a semicircle. For the time being, I am drawing arc. I am not drawing a semicircle, I am drawing an arc which is having this positive charge distributed around it. And now I am drawing a center line just for symmetry. And if the arc length is of the radius is r, so we are considering something like this, that the radius is r and it is subtending angle alpha on both sides. So in order to get this solved, at an angle theta, we are selecting a small patch d theta like this. So from the center theta, we are selecting a small patch d theta like this. So the length of this portion is going to become r d theta. So angle is equal to arc length upon radius. So we are calculating the arc length is r d theta. So if I write the charge on this particular segment, we say lambda is equal to dq and the total length is r d theta. So from here we can calculate the small charge dq as lambda r d theta. Now due to this small charge, an electric field is produced in this direction, suppose dE. And there is a component of electric field which is going to act in this direction. This angle will also become theta and it can be written as dE cos theta. And this component on dE sin theta is going to be balanced by the electric field on the other side. That is, this portion is producing an electric field on this side, this portion is going to produce an electric field on the other side, and the net summation is going to be 0. So we are writing electric field along y-axis as dE cos theta. So we can write it as, this dE can be written as k q, that is lambda r d theta upon r square, and we multiply this with cos theta. So this is the particular equation we are looking for, and if we integrate it out, so we get it as k lambda upon r integration of cos theta d theta, and the value is going to be from minus alpha to plus alpha. So if we solve this particular equation, we get it as k lambda by r and integration of cos theta is sin theta minus alpha, and then this is plus alpha. So we get this as 2k lambda by r into sin theta, where it must be very well kept in mind, sorry, sin alpha. When we put the value, we get it as sin alpha. So now over here one thing is evident. For this particular question, it is saying that there is a semicircular arc. So if it is a semicircular arc, so the angle alpha is going to be 90 degree. So this is going to be 90 degree. So if I put the value equivalent to 90 degree in this particular question, we get the magnitude of electric field as twice upon 4 pi epsilon naught. Now we are putting lambda as charge per unit length, that is q by L. The next thing is to put the value of radius. So what is going to be radius? So I say that the total arc length is going to become equal to pi r, and pi r is equal to L. So I can write pi r is equal to L. So L r can be written as L by pi. So over here we are writing r as L by pi, and this is equal to sine 90 degree, that is 1. So if we put all the values correctly, we get it as q upon 2 epsilon naught L square. So this is the answer for this particular question.